Welcome to our solar cooker project optimization experiment. So first, our experimental question is what angle optimizes the rate of heating of the sample. So if we look at our variables, our independent variable is the angle of the solar panels, which differ by 10 degrees from 120 degrees to 160 degrees. Our dependent variable is the temperature of water inside of the black test tube or container encompassed by a plastic bag. Now let's look at our control variables. The first control variable is the amount of water in the tube, which is fixed at 30 milliliters. We must have the same amount of water in the tube for all the trials because smaller amounts of water have faster heating rates. Therefore, if the amount of water is changed, the heating rate, which ultimately affects the maximum possible temperature, will be different. The second control variable is the tube that is used, which is a larger size. The tube that is used must be the same for all trials because different sizes can hold different amounts of water and change the concentration of the water inside the tube. For this reason, it is crucial to use the same tube for every trial wrapped in a black tape and a green plastic bag. The third control variable is using the same lamp. The type of lamp must be consistent throughout the trials because different lamps emit different amounts of heat, thus having an impact on the heating rate. Now our fourth control variable is the height of the tube and the solar cooker, which is fixed at 3 centimeters. This must be controlled because having the tube closer or farther away from the light affects the rate of heating of the water inside. Now let's look at our last 3 control variables. The first control variable of the last 3 is the height of the lamp, which is approximately 34 centimeters above the table. And this needs to be controlled because just as with the height of the tube in the solar cooker, the closer the source of heat is to the water, the faster the water will rise in temperature. The second one of the last 3 is the position of the light, which is shining down from the table at an angle of approximately 30 degrees. The angle is important because we want to maximize the light rays hitting the solar cooker. Now, the last control variable is the solar cooker placement, which is on the stool. And this is really important because we need to control the distance between the solar cooker, the tube, and the light itself. Now I will talk briefly about the position. So if you look closely, the lamp is in the background. We have our plastic bag covering our black test tube and our solar cooker prototype. Now I want to show you which angle we measured for the optimization experiment angle. Now our procedure. Step 1. Prepare a solar cooker prototype, a black test tube, a plastic bag, and a lamp. Step 2. Measure the angle between panels and make sure all angles are at 130 degrees. Step 3. Place the solar cooker on a stool and the lamp on the table so the light shines down at an angle of approximately 30 degrees. Step 4. Put 30 milliliters of water into the test tube and put the test tube in the plastic bag. Step 5. Place this test tube on the holder. The height of the test tube holder is not important for this experiment, but it must remain the same for other trials. Step 6. Turn on the lamp and start collecting data on Logger Pro. It should last for 15 minutes per trial. Step 7. When finished, repeat steps 2 to 6 with different angles. The distance between the tube and lamp, angle of the lamp, and the amount of water must be consistent for next 4 trials. Thank you for watching our solar cooker optimization experiment.